Hello, Mr. Harry, Mr. Ryan, are you right?
Yeah.
Okay, so last lesson we talked about combination sum. So there are 9 numbers. We want to pick k numbers. Let's sum up to n. Yeah. We want to return such a list of this sublist. So for example, when k equals 3, we want to find the 3 numbers. You can pick the 3 numbers from 1 to 9. We want to pick 3. Each number can only be used once. And can we find such list that sums up to 9? It could be many, yeah. For example, like 612, 31, 315, 214. Okay. Last lesson we talked about the backtracking, which is kind of like depth search. Yeah. We try to go as deeper as we can, and we realize that at some point there's no point continue. There's no point continue. These 3. Yeah. There's no point continue based on the current state. There's no point to continue. Then we just backtrack to the previous state. Okay. So there's no point wasting time searching a subtree when we realize that there's no point doing so. So for example, if for each node we can store the current choice of numbers, and if we find out that we have more than k numbers, there's no point to keep adding it, right? There's no point to keep adding it. And also, if we find out that the sum of the current choice is more than n, and there's no point to keep adding it. Why is that? Because if we keep bringing more numbers, then there will be obviously more than n, right? Which is not the thing we are looking for. Okay. Okay.
Yeah.
So we also talk about the iterators. From iterators, import combination. So and also we can use the permutation. So for return x for x in combinations. The first parameter will be the choice, the iterator. So we are giving it range 110, meaning that we have 9 numbers, and we want to pick k numbers as a combination. And then we can use the list comprehension. Return x for x in this. This is the brute forcing. The brute forcing all the combination, right? And then if sum equals n. Right? And we can also use the backtracking. So how do we backtrack? So we keep adding the numbers, until we find a solution. So basically it's like define. The depth search, we have this current list, and then we have the current sum, and then we have these current numbers. Right? Current numbers I. If current sum is bigger than n, or if the length of current is bigger than k, yeah, because if we have the sum more than n, or we have the more than k numbers, then we just return. And then the other thing we need to check, if current sum equal n, or the the current equal k, then we find the one list, then we need to append it. So answer the append current, and we need to make a copy of that, right? Otherwise, we just check the next number for x in range. We check from the I to 10, up to 10, not including 10, to 9. Then we do this depth search. If we use the current number x, then what is current plus the x, the sum will be updated, current sum plus x, and the next number we can use is x plus 1, right? Okay?
Yeah.
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 And we can just, at the beginning we try with the empty list, and the current sum is 0, and we start with the first number, easy, okay? That's the depth search, backtracking. Okay, so coming back to this combination, we can actually replace this combination, yeah? If we define this combination, okay, COMB combination. So if we want to replace this current I, we want to have this current combination, which is the first parameter will be the current list, current choice. I will be the next number. Okay, so then we need to, if length current equals k, then we can year. Yeah, what's the year current and return. Otherwise, we can just try for for x in range I to the 10 up to 10, not including 10. Then we can year from what? Current plus x, and then x plus 1. Okay, so basically this function is just to generate the iterator. Be meaning this promise. Yeah, I promise you I want to generate this for you when you need it. So this current list, and that's the number that we can pick, right? For example, if this is 2, that meaning that we can pick the numbers greater or equal than 2. Okay, and then for each number, we can just try to the year from, okay, year from, and then this is the recursion. Year from combination, current plus x plus 1, okay. This is the combination, and how about the breadth search? What kind of data structure we need to use to implement the breadth search? Yes, a queue, and in Python specifically it's DQ, double and DQ, okay, double and Q. So it's just because we have this tree, right? We have this tree. We can visualize the search by the tree. So at the beginning, we start with the empty list, right? Empty list, and then the tree. The first node would be if let's try to put the number 1. Okay, if the number 1, that's still okay to add more numbers. Then we start with the number. We add another number 2 and keep going. Number 3. Yeah. So. For the backtracking depth search, it's going down as deep as we can, and if not, we go back. But for the breadth search, we're doing level by level. So we try the first number, we try the second number, with the number 2, number 3, etc. Okay, so level by level, we're using the DQ. Okay, so let's implement this defined breadth search. At the beginning, with the Q equals DQ. And then we given this tuple. The first one is the empty list, and the sum. The sum will be 0. The next number we want to try, we can try from is 1. Okay. And then wire Q, wire Q. Why there are elements in the queue? So we need to find out how many of them. Let's say size SZ equals the length of a queue. So if we get this SD, so it means that there are SZ numbers of nodes in the current queue, which belongs to the same level. And then let's pop it out each by each, okay? So in range SZ. So now we have this current sum, and the x, the nodes we can try, equals q dot top left. We're taking from the left, first in, first out, yeah? So we need to DQ from the left of the queue, okay? Yeah? Now, so then we can try, if the sum equal n, and the length of the current equal k, then we can just answer the append a copy of the current, okay? Copy of current. Else what? Else if current, we want to find out. We want to find out what? Else if the length of the current is smaller than k. Yeah, we still have numbers to pick, and the sum, the length of the sum is smaller than n. Yeah, the numbers we pick do not exceed the sum. Okay, then we need to go through the numbers. For I in range, we start from the x up to 10, not including 10. Q dot append current dot plus what? Current plus the I. S plus I, the sum needs to be incremented by I, and then the number needs to pick is the I plus 1 next. If we pick the number I, the next number we can pick is I plus 1, and that will be, yeah, that will be. Let's breadth search. Okay?
Yeah.
So what have we learned today?
Combination thingy.
So what are we doing today?
So we're adding numbers.
Yeah, so come on, explain to me what do we learn? What's new today? What?
The problem is there are only numbers 1 to 9.
Yeah.
And you only can use each one number 1.
Yes.
And you have to make the target whatever it's called.
Yeah. So we talked about that the day before yesterday. So what's new today?
DQ.
What's DQ?
DQ is double M DQ.
Yeah. What's the acronym? Come on.
Breadth search.
Yeah, breadth search. Yeah. Last lesson we talked about the depth search, backtracking. Okay. So today is just breadth search. For the breadth search, you use the DQ, but with the DQ, we need to store all the nodes of the same level. But with the depth search, we don't need to store all the nodes in the same level, right? We just follow a path as deep as we can, and if not, we just go back. Okay? Yeah. Okay. That'll be it for today. Bye bye.
Bye-bye.
Bye bye.